we are going to be looking at how to graph rational functions. A rational function is the ratio or fraction of two polynomial functions. In order to sketch the graph, we are going to find all the intercepts and the asymptotes. We have a process that we are going to follow. The order of the steps is not important. The first step is to find the y-intercept by setting x equal to 0. Let's look at the given function. We will set x equal to 0 and solve. We get -3/2 or -1.5. This means the graph crosses the y-axis at -1.5. The next step is to find all the x-intercepts by setting y equal to 0. Remember that y is the same as f of x. The easiest way to solve this is by cross-multiplying. Notice that you end up with just the numerator equal to 0. This is a good shortcut to remember. Our results show us that the graph crosses the x-axis only once at x equal to -3. The next step is to find the vertical asymptotes. We find these by setting the denominator equal to 0. Recall, this is also how to find the domain of a rational function. These are the values that x can never equal to. Vertical asymptotes can never be crossed. We have one vertical asymptote of x is equal to 2 that we will represent with a dashed or dotted line on our graph. The next step is to find the horizontal asymptote. This asymptote describes the end behavior of the graph. Most rational functions flatten out as x grows very large and as x gets very small. The graph can cross a horizontal asymptote. We find this asymptote by comparing the degree of the numerator to the degree of the denominator. You can see the formula if the degrees are equal. The asymptote is the ratio of the leading coefficient. The degree is the largest exponent. In this function, the numerator is degree 1 and the denominator is degree 1. The degrees are equal, so the horizontal asymptote is y equal to the ratio of the leading coefficients, which also happen to be 1. We now need to put all this information on the graph. We have the horizontal asymptote of y is equal to 1. We have a vertical asymptote of x is equal to 2. We have a y-intercept at -1.5. We have an x-intercept at -3. We now need to plot some additional points. I'm going to use a calculator to help me. But these 2 points that we have suggest that the graph gets close to the horizontal asymptote and then continues downward close to the vertical asymptote. Remember, the graph will never cross a vertical asymptote. Since we know what the graph looks like to the left of the x equals to 2, what about to the right of the vertical asymptote? A table of values will help. When x equals to 3, y is equal to 6. As we plot this point, it indicates the graph is going way up along the vertical asymptote. Let x equal to 5, and we get y equal to 8/3. Now we can see the graph is decreasing and is approaching the horizontal asymptote, the end behavior of the graph. This is a good sketch. Let us go through the entire process. The y-intercept is found by setting x equal to 0. This is where the graph will cross the y-axis. The next step is to find all the x-intercepts by setting y equal to 0. The easiest way to do this is by cross-multiplying. Notice that you end up with just the numerator equal to 0. The next step is to find the vertical asymptotes. We find these by setting the denominator equal to 0. This time we have to factor. We get 2 vertical asymptotes. The next step is to find the horizontal asymptote. We find this asymptote by comparing the degree of the numerator to the degree of the denominator. The degree of the numerator is 1 and the degree of the denominator is 2. When the degree of the numerator is less than the degree of the denominator, the horizontal asymptote will always be y equal to 0. We now need to put all of this information on the graph. We have 2 vertical asymptotes. We have the horizontal asymptote of y equal to 0. We have the y-intercept at -0.5. We have an x-intercept at -3/2. We now need to plot some additional points. Let's choose some points to the left of -3. Then we will choose some points between -3 and 2. Last, we will choose some points to the right of 2. As you plot the points to the left of -3, you should see the graph is getting closer to the horizontal asymptote. We know it does not cross it because we only have one x-intercept at x equals -3/2. The points between -3 and 2 indicate the graph is going up closer to x is equal to -3 and then downward along x is equal to 2. The points to the right of x is equal to 2 show us the graph goes up along x equals to 2 and then falls, getting closer to the horizontal asymptote. We will follow the same process in this example. Find the y-intercept. Now find the x-intercepts. I am using the shortcut of just setting the numerator equal to 0. This time I will need to factor, and I get 2 x-intercepts. The vertical asymptotes are found by setting the denominator equal to 0. I get 2 of them. I now find the horizontal asymptote. I need to compare the degrees of the numerator and the denominator. They are equal, so the horizontal asymptote is y equal to the leading coefficient of the numerator divided by the leading coefficient of the denominator. We put all of this information on the graph. As we plot the intercepts, you should notice the graph peaks at the y-intercept and then falls to the right to cross the x-axis and also falls to the left to also cross the x-axis. Once the graph gets close to a vertical asymptote, it is not just going to turn in the opposite direction. Now we need some additional points. Let's pick some numbers to the left of -1. As you can see from the y values, the graph goes up on the left-hand side of the asymptote and then dips below the horizontal asymptote. So now let's choose some x values to the right of 2. You can see that the graph goes up on the right-hand side of x equals to 2 and then continues to fall, getting closer to the horizontal asymptote.